All right. All right, let's do one thing here. So the audience or the others can see what we got here.
Oh, and Steve put the certificate we got for Winterfield.
All right.
That told us the baronet's coming up, but don't forget.
Okay, yep. All right, let's see if we can get this in a little closer. Ah, okay. Oh, that looks good. That looks good. Okay, you can move that back a little bit. And you can even see my face. Okay, we'll get started. I'll try and keep this brief. It's going to be on the basics. I'm going to mention a few things, and many of you are guilty of it. But I want you to understand I'm not singling you out, because we all do stupid mistakes. Myself the same way, but there's some gotchas, I call them repeaterisms, that we get into. And also they say a picture's worth 1,000 words. So anybody that knows me knows you get the picture and you get the 1,000 words. So if we're ready, we'll get going. Okay, first off, basically with a repeater. And for right now, just concentrate on what's right here. Turn on the trusty bow thing. You can hold that right over there. All right, I've got this set up different frequency in and out. All right, you start off with a repeater. Basically what you got in it is a receiver and a transmitter. And normally with a 2-meter repeater, it's the receiver is either running 0.6 megahertz, 600 kilohertz, above or below what your repeater output frequency is. So in other words, like locally, I use a couple of repeaters locally. The 7.3 repeater, 146.130N, up 600. The output of it is 146.73. And with 2-meter repeaters, once you get 147 megs and above, it reverses. So if it's 147 megs above, generally your input is 600 kilohertz higher than what your output is. So like the 147.00 down in Red Rock, Pennsylvania, that's 147.60 in, 147.00 out. And so on the 3.6 repeater in Elmira, 146.960 in, 147.36 out. So that's your offset, your minus and plus. You'll see 146.73 minus. So that's your standard repeater. You transmit into it, and it retransmits at a different frequency out, usually in 2 meters, 600 kc apart, or kilohertz. You got to remember, it used to be kilocycles and megacycles years back. So us older guys, we're still sometimes in the old thing. It used to be microfarads, not picofarads, and some of that. So showing my age. But anyway, if it's a UHF repeater, generally it's a 5 megahertz separation. Below like 145 megs, it's 5 megs high. So 140 or 444 plus 5, 449. But 445 and 5 brings it to 450. Nope. So at 445 megs, you're out of band. So, but at 444.9, then you could go in and be, or yeah, 444.9, and you could go in at 448 or 449.9 and still be in the ham bands. So, okay, but one of the things with the repeaters, and basically I'm hitting right now at the standalone repeater, like the 7.3, the 3.9, and 7.6 and a WeGo, the standard repeaters that most of us deal with. I'm not going to worry right now about the 8.2 and the 8.65 because that's a little different animal. But the standard repeater is you got the receiver and the transmitter. And okay, with only 600 kilohertz separation between them, that's like 146.130 and 146.730. You cannot put those two close together and have it work. And anybody that's got the idea of putting up a repeater, hey, I want to put up a 2-meter repeater. Let me tell you something. There's one big thing you need. It's called a duplexer or cavities. If you don't have the money for the cavities, don't even consider the repeater. The cavities for 2 meters is made up 4 or 6 of these. You'll have like 2 or 3 on the receive side, 2 or receive on the transmit side. And they got jumpers that go between them. On the output of the duplexer, like say on the transmit, you got a little tail that comes out there and they're all pre-measured lengths. And on the receiver the same way, they come out to a T connector. And that goes to your antenna. Then your other ends coming out, one goes to the transmitter, one goes to the receiver. What does that do? That is a very narrow passage. So what it does, and we'll use the 7.3 as an example, it allows 146.130 to come in from the antenna, pass through these cavities, and into the 146.13 receiver. At the same time, it allows the transmitter to be transmitting 146.73. It's going through the other set and sending it up to the antenna. So now you've got maybe a 50-watt signal going up and a signal that's microvolts coming down on your receive. And you have to keep them separated. And it takes these. 4 of these will give you about an 80 dB separation between transmit and receive. 6 of them, 3 on each side, will give you upwards toward 120 dB. If you don't use the cavities, you key the radio, and all it does is the repeater hears itself because it just loops right around. Okay, these things here, and Bob, you can verify for me. Going price for a set of 4 of these is about $1,500 or better. If it's 6 cans, it's more like $2,000 or above. So if you can't afford those, don't even consider putting up a 2-meter repeater, because the only way that you can go without these is you put the transmitter one place and the receiver someplace else. And I mean more than 500 feet away, if they're horizontal distance. If you're going to put them vertical, one under the other, you probably need 100 feet or better to hopefully get some isolation, but it's still a problem. We had a fellow years back around here, he's sound key now, but he tried to work without cavities, and a fellow by the name of Stan Progi, a very smart fellow in the whole works, but he tried to save money and not use cavities. And he's the one that used to have the 145.47 repeater, and he was forever having problems with it. You got to use the cavities. You got to use the duplexer. Bob.
The cavities cost more than the repeaters.
Yes, yes, yes.
Do you
Joe.
have to tune the cavity?
Oh, yes. Oh, yes. Okay.
Yes, I
Quick lesson on the cavities.
Not easy to tune if I remember correctly.
Right. It takes precision equipment. And basically, now there's different ways they do it. This particular one is what they call a pass notch or pass reject cavity. It's this top slug here is a bandpass cavity. So an easy way to do it, I like to use the door analogy. A bandpass, that door is so wide. If it's narrow, guys like me can get in. If it's, but some of you other bigger guys, Josh, I'll pick on you. If it's narrow enough that I can get through easily, Josh is going to have it get caught. So so it does the same thing with the signal. It's a narrow filter that lets it pass through. Now, the other thing is the notch or the reject. Some of them, it's a little trimmer capacitor up here that you adjust. And what that does is that rejects or notches the other frequency that you don't want. So the one that's receiving the 146 receive signal, the notches are working, are tuned to 146.7.3. To notch that out, and likewise on the transmit side, just the opposite. Some of them, like I say, they got a trimmer capacitor for the notch, and this is the band pass. This particular type is a Wacom. I think the people that ran Wacom used to work for DV Products, and they decided to go form their own company and make cheaper duplexers. Well, they came up with this idea, this trombone on the side, which is a capacitor. It's a Rexolite rod with this sleeve here, and inside the rod there's another thing. So basically, it's a trombone capacitor. You loosen the cable clamp here, slide up and down. It's a variable capacitor. You set the notch there. So this was the big thing they used. A lot of hams used. Well, they work so great, the company's out of business. Because people that have worked with these said you couldn't hold this notch. They wouldn't stay. Inside the cavities, precision. It's silver plated. It's a copper cylinder in there, silver plated, and then you've got a slug that goes up and down through. It looks like a piece of copper pipe, an inch in diameter. There's some of that. No, wait a minute. I'll take that back. No, it's got finger stock that slide on this other. This one copper tube is like three inches in diameter in here, and then you got this other thing that slides in and out as a slug. And it's got what they call finger stock on it, or what have it. It's little fingers that go into the inside of the other diameter, and they tune this. And what it is, it's the piston type capacitor. Is what it is. But why do they use the silver plating? Because you don't want corrosion and that stuff, because that's going to affect the tuning. And that slug that they use is what they call invar. I'm not a metallurgist or any of that, but what it is invar is a type of metal that changes very little in characteristics with temperature change. This cavity right here is at room temperature. But if I take it out and put it on Bob's repeater out there in the green building, that's whatever the temperature is. If it's going down to 10 above tonight, that's what the temperature of that cavity is going to be. You want those cavities keep their tune, because when they go out of whack, then you get the descent in your repeater and all that stuff. So it's precision thing, tuning it. The best way is they use what's called a tracking generator. It generates a signal and it looks at the other, so you get a scope display and you can watch where the pattern is, and then you can bring the notch in and you can watch them come together and all work. So, but it takes somebody with good equipment. It takes their time to do it, because you go back and forth. And the thing is, if you got 4 or 6 of these, you got to do each of them, and then you go back and adjust a little bit more. So you don't just bang, 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 and they're all done. That may be why how the commercial shops do it, but us hams, if you want to work right, you got to take your time and do it. I know a fellow right now that's tuning cavities for Bob for his repeater that's going on over at the university. He tuned it some weeks ago, and he's letting it set, and he's been checking it to make sure it doesn't change over time. And this guy tuned up special cavities and the whole works that are being used on NYSEG's trunk system. Motorola put the system in, but it was specified they wanted him to adjust the cavities to do it, because these were on a combiner system where you had a number of receivers or a number of transmitters at different frequencies on these. So anyway, it takes good equipment. So, okay, so that's in a nutshell what a duplexer cavities are for 2 meters. And the thing that hurts for the hams, the expensive thing, is that 600 kilohertz split. One of the biggest mistakes they made with 2 meters, and what would be nice if we could change it, when they started putting repeaters on 2 meters, they should have gone to 1 meg splits. It would have made it a lot easier. And if you check prices, a duplexer for ham use, 600 kilohertz split is expensive. You can buy that same set with a 5 meg split on it, and you can pick it up cheap, a lot cheaper. Now, let's just take an example. At VHF. See that right there? 1, 2, 3, 4, 5, 6. That's got 6 cavities in it. See the adjustments there? That will do the same thing as this, except it's got to be a 5 megahertz split. And VHF. You could use this on 2 meters. If I could go 5 megahertz out of the band, I could use this. And let's see, let's see, 1.2 dB loss, 80 dB rejection. So with this here, with a 5 meg split, I can get the same rejection as I can with 4 of these at about $1,500 or so.
Or
Yes.
is that a commercial repeater, or what is that?
Yeah, this right here is a Yaesu fusion repeater. They'll do both analog and the C4 FM.
Okay, that's out of that one of those?
Yeah, yeah, no. This right here is what they call a mobile duplexer.
Oh,
You older guys will remember it, young guys probably don't. But years ago, before cell phones and what have you, they used to have mobile telephones in cars that you could get. You could have a mobile telephone in your car and talk just like you do on a regular phone. I believe input was at 152 megs or around that area, and output was around 158, 159 megs, somewhere's in there. They call it the MTS, the mobile telephone system. And that's what used to be back before cell phones came out. And so what you did is this was mounted in your mobile. And you had your phone with a handset on it, just like your old Bell black phone that some of us used to have. But it was a 2-way radio that was a mobile phone. It transmitted and received at the same time. So you could talk back and forth and not have to over. Nope, you just talk back just like you do on a phone. Full duplex, they call it. So that's what that was used for. But now with cell phones, mobile telephone like that are gone by the wayside. But some of these are still around. What do I use this for? Well, I got this set to reject at 152.5. That'll take some of the paging out and what have you. So you tune these right, you can use them as a reject unit to take trouble out. Now, just last thing on the duplexers. I mentioned for UHF. Right there is a full 4-cavity duplexer for UHF. 5 meg split. Okay. See if it's got, okay. 50 dB of rejection, 10 dB loss through it, 50 watts maximum on it. So that is duplexer there that you could use. Some of the hams right now are using 4 or 6 can sets of these on their UHF fusion repeaters. Because you got the 5 meg split, you could take one of these, put it with this repeater, program it for UHF, and there you go. You got your repeater. But the beauty of it is the 5 meg split makes it a lot easier, cuts the cost down on it. These can be bought for less than $500. And but as soon as you go to VHF, it's a different story.
Did you say 10 dB loss?
Let me see if I'm reading that right. I can't.
it's 45 watts.
Yeah.
Okay, 50 dB isolation. This is 10 dB loss, but yeah, that don't sound right. No. No, I would think more like 1 dB loss or so would be your
Maybe it's 1.0.
Yeah.
Yeah.
Decimal point got more.
Yeah, that could very well be.
Bridgecom is actually making a UHF repeater now with the duplexer built into the repeater.
Yep. Some have them, some of them are on the top, some are right inside. And so there you go. Okay. Now, couple, yes.
The Yaesu repeater doesn't have any cavities in it?
No cavities in it at all. Two mobile radios are inside there, coupled together. Yep.
Okay.
Nope. Unless, like Bob's saying, there's some repeaters that got the duplexer built in, like on a UHF, but none of these others. Nope. You're gonna use this as a repeater. It's gonna be on 2 meters. You need the duplexer, 4 or 6 cans of those. Or 4 or 6 like this for UHF. Okay, now a couple of things here. Let's just do this. I got this set up into a dummy load.
Ford, how much of the space versus anything else like the inside the how do you call it?
The enclosure for the repeater?
Yeah. How much like what's inside it and how much space there is versus
Oh, okay, well, inside here, if you take the cover off, there's copper pipe. Looks like a piece of copper pipe, about 3 inches in diameter. And then inside, you'll see another cylinder. It's got some fingers on it that rub on the inside of this, and that's probably about 1 inch in diameter or so. And that's tied to this screw here. So it'll go up and down, and then it's all plated inside, silver plated. Now, if you're talking about how much room that it takes up at a site, take this. So,
I mean, how much space inside versus the
not much. These are about what are they, 4 or 5 inch. So you got about maybe 1 inch less diameter. So if this is like a 5 inch cavity, it's probably 4 inches of what that pipe is inside.
So the space inside minus is like a quarter of versus the pipe and the other stuff are the foil are taking like 3/4 of the space.
Yeah, something like that. See, that space there doesn't really make the difference. What makes the difference? Make sure I got a hold of this, because the guys that carried in, I says, don't drop it. That's the last thing you want to do. You don't want to dent this or any of that. This is approximately a quarter wavelength, this tube inside here. Now, I'm not going to go into the theory and the whole works. You guys can get out the theory books and the whole works and tell us how a resonant cavity works. As that's what this is a resonant cavity. But otherwise, space-wise, okay, 3 of them will be about to here and about this wide. So this whole thing is at a repeater site. You got to have these all there. So, okay.
You can see the Motorola cabinet behind the screen there. My repeater and my cans will just fit in that when it's all stacked together.
Yeah. So, yeah, this. Been down what Drew's got some other equipment, but there's a cabinet with all the stuff in it. So like Bob is saying, he's got like his repeater. I think it's on the top, isn't it, Bob?
Yep, way up top.
And so then down the bottom will be his duplexer. But because the duplexer he's got is a little bit smaller. And so that's how he got away with it. All right, now.
Oh, I think he's just talking about the size. Yeah.
Okay, so basically what it is here, now this repeater right now I got set. Okay, so it's set. I'm going to make it easy. I'm going in on UHF. I'm coming out on 2 meters. So right here, you got the radio. Okay. AB2HS testing. Okay, we'll try it that way. AB2HS testing. So see what I'm doing is that repeater is acting as standalone. I'm transmitting to it on UHF, and then it's transmitting out on 146.865. So
are you using a digital mode? Is that why the latency there?
no, that since the repeater will do digital, it's got latency built into it. I don't know why, but it's got a delay.
Signals get delayed like that?
Yeah, it does. I don't know. That's the way Yaesu does it. And if you I'll get into it in just a couple of minutes, but if you listen to 8.2 on one of your radios and listen to 8.65 on the other, you'll hear the delay, because the 8.2 repeater right now is one of these sitting listening to UHF that's going to Ingram, And it's also being received on one of these is transmit on 8 too.
I
But the,
suspect it's doing analog to digital and digital to analog then, because pure analog. wouldn't
it could very well be, because actually with these repeaters, these digital voice repeaters are actually analog repeaters. The only thing that's different with the digital is the way you modulate it. It still puts out an FM signal, but instead of sine wave audio that's frequency modulating that carrier, the digital signal is frequency modulating it. But still, in there, the innards of the radio, it's still got an FM detector in it. And the whole works just like any other analog radio. Okay, so that's basically just to go back, a receiver and transmitter, transmit into it on one frequency, come out on another. Now, let me show you something here. Gary, you got that? Okay, I'm talking right here. Let's see, I'm on high five. And this is one of the things I hear on the air. New guy comes on. You can tell the old guys have been on HF for a long time, or the new guys who just got their license. Hey, I'm testing out my new radio. Can you hear me okay, Gary? And he answers, oh yeah, I can hear you. You're real good. Well, let me change my power. So I change my power. Hey, how do I sound? Well, Gary says, well, my S meter says it's an S9. But you're still S9. Hey, that radio is working good. Number one goof. What happened? You are not listening to my signal off of here. You're listening to the signal off of the repeater. So the new guy, hey, you keep changing power and you're still the same. You're listening to the repeater. If you want to hear all the other guys' signal strength is, you got to go a lot, like say in the case of the 7.3 repeaters, you got to listen on 146.13. Then you'll hear really what he is. Otherwise, you're just listening to the repeater. And okay, so that's one of the first gotchas. All right, then we'll get into the rest. Now, so that's the standalone repeater. Now to go, I'm on. So this idea that I just told you, that's pretty much the way most of the repeaters are. Now we're going to shift gears a little bit, and we're going to talk about the 146.865, 146.22 system. And this gets a little more confusing, so I'll take it one step at a time. What we've got is at present time, I think it's 6 locations that can be up to 7. 7 remote receivers. I didn't bring a power supply to turn these on, so we'll pretend that it's on. Okay, you see I got 2 radios here. These are Motorola Radius radios. On the back, you'll see the fan for cooling, and you'll also see right here. No, wait a minute. I'm trying to see it right here. This gray wire. See it going from one radio to the other? Well, one of the beauties of this is that accessory connector. If you ever hear people talking, or I'm asking somebody, does it have the 16 pin on it or the 5 pin? If you got the 16 pin, what they do, Motorola is nice for doing some of their stuff. You can hook to other things. On this 16 pin connector, you got push to talk, transmit audio, receive audio, COR, COR with PL, COR without PL, and what have you. So with this cross connect, and on this, you'll see there's a little pot here. You can also set your level if you need to. But with this little arrangement, with a couple of Motorola radios, I think Ken would, some of the others do it too, but Motorola was, for doing this, you got the equivalent of portable repeater right there. But once again, if you're going to use it as a repeater on the same frequency, you got to have the duplexers and the whole works. So here you can pick up 2 of these radios, $50 a piece. Hey, I got a repeater. But now you got to spend $1,500 for the duplexer to have it work. Well, what I do with the 865 system, the voter system around here, and we are one of the few that's got it. Years ago, W2QAL, we had the dream of this. And then later, after he died, and Brian 80, K2DLB, we still had this idea, we wanted to try a voter and remote receivers. Well, thanks to being able to get a hold of this stuff that came out of service, $50 a radio and what have you, we were able to put together this system that we've got now. So, all right, why do we do it? All right, you guys know, and I'm not knocking 7.3 or any of that, but you guys know in some of the cases with 7.3, people in different places can't get into it. If the wind's blowing, you got all kinds of noise. Well, part of that noise is the antenna they're transmitting and receiving on it. And up on Ingram Hill and other towers, you got loose hardware. Well, and all that high RF, when you got a high RF going against ground or what have you, you get sparking. That's your noise you hear, or moisture, rain, wind, all that. So, and you can get interference from other services and what have you. So what myself and the fellows prior to me, we put this voting system together. So at 6 sites, and for right now, I'll concentrate on just this one out here. It's on the big tower. Because most of our, well, in fact, when we get done, all of our receivers will be on county towers. I got, there's one left, the one at Lyle, that's going on to a new tower. At present, that's in the guy's shed in his backyard. But that'll be going on to the tower thanks to the county. They wanted amateur radio backup. So they want me into these sites. So at each site, we've got one, a set of this. 2 of these radios like this, a power supply, and 2 antennas. You look out here, you'll see the second antenna down on the road side of the tower is 4 stacked dipoles. Loops that from the ground look about that long. That's what they are. They're halfway length long at 2 meters. 4 stacked dipoles. And if you look close, at the right angle, you'll see an antenna like this. It's up there, and it's aimed toward the airport. Okay, what I am doing at these sites, and we'll use this one here, I'm coming in on the bottom receiver. The bottom receiver is scanning. So one of the first things I want you folks to remember, when you're dealing with a system with the remotes, they are scanning. They are listening to both 146.22 and 146.265. Just like your scanner, it's got at home. It's used for the police. Sheriff, Binghamton PD, keep going around, and the first one that comes on, the scanner stops, you hear it. That's what these do. They're sitting here, now like this bottom one, let's see, that's probably, yeah, okay, I think that's a 16-channel scan. And basically, I either, every other channel is the same thing. So the odd channel is maybe 265 receive, the even channel is being 22 receive. Or I may just do 1 or 2. The whole thing being, if you remember with your scanners, you got a 20-channel scanner. Whatever, going around like that. Well, now you got a 40-channel scanner. It's still going the same thing, but now you got 40 channels. So there's a time of from channel 1 to 40 before it gets back to channel 1 again. So if you keep putting the same frequency in side by side, it faster, when it starts scanning, you can pick them up quicker. So you're shaking your head, Alan.
No, I just want you, on most scanners, you could just lock out the channels you're not using.
Okay, but see, on this, we want to scan 2 channels.
Right, so you can't lock the other 18 out?
Right, you could, but I'm making use of them. Well, yes, I believe you can. Yeah, I think you can. So yeah, I could do that. That would be a logical way to do it too. But on some of it, of course, remember that programming these radios is done with a special Motorola program that isn't readily available. You kind of get it on the black market. Really, in the strictest sense of the word, any of us that have that program, we are not a Motorola service rep. We could be arrested for it or what have you, but there's so many of them out there that, and now it's so old. The technology on this, you computer guys, you program it with a DOS computer. A Windows computer is too fast for it. This thing is working on the data line on the, I think it's the transmit audio and speaker line or something. There's something on one of these mic pins. That's it, but you're running a serial port connection off a DOS computer. So that's all I know about the computers, but I know it's not a Windows type thing. This is a technology that they're using on it. So once again, for some of this programming, I'm not the expert on it. So some of it's easier lots of times to just put those extra channels in rather than try and finesse it. And the way you get it in the scan is a little different than what you do with your Bearcat you got at home. But anyway, it's scanning both channels all the time. And then it transmits out on UHF. So like say from here, okay, well, let's hold up just a little bit. Time for another swig. Okay, repeaterism number 2. And what you guys have done this. Hey, trying out my new radio. I'm on 865. How do you hear me? Hey, I hear you good. I hear you good. All right, I'll go over to 82. Hey, how do you hear me? You hear me good. Okay, where's the fallacy?
They're both the same frequency at the receiver.
You're coming into the same radio. You're just stopping on a different channel. So, so fallacy number 2, and there's a number you can tell the new guys because they're the ones that fall into that trap. Because the system, all right, these computer sites. Let me give you a quick one on that. Copernic out here, we've got a receiver. Twist Run Road at the water tank on Twist Run Road on the north side of Endwell. There's one up there. At Lyle, it's up near Center of Lyle. It's not far from, it's just the hill across from the rest area. The Whitney Point rest area that sits between Marathon and Whitney Point. That's the Lyle remote. We've also on Old State Road, on the tower there, we've got another remote. And that's it for right now. Coming up, you will see, if you look close, this says Navinger on it. Navinger Hill. Well, where is that? You ever hear of First Pond? Harpersville? How about Center Village? Well, anyway, okay, Harpersville is right off Route 88. So when you get to the Harpersville exit, when you're heading toward Afton, look up on the hill. You'll see 2 big towers. You'll see a cell tower up there, but behind it, you'll also see an A-frame tower. It looks just like this one out here, because that's what it is. It's another county tower. It's Navinger Hill Road. First Pond Road is on one side of the hill. Navinger Hill Road is on the other. And then east of that hill is this pond of water called First Pond. But it's up there, so that's Navinger Hill. This radio right here is ready to go. Probably I'll get Rick to help me with that because he was up near there. We got to take that up, set that on a rack, and I connect to the cables that are already waiting for me. And once again, at that site, it's got a 4-stack dipoles on the tower, and up about halfway up the tower. Originally, it was going to be on the top of the tower, but it's about halfway up there now. We got one of these that seemed westward toward the airport. Okay, once again, come in on this particular one, come in, scanning on 146, 22, or 265, and it transmits out on a UHF frequency. And okay, so that's the receivers.
Are all the sites receiving the same 2 frequencies?
Yep.
Why 2 instead of just 1?
Next thing.
Okay.
Next part.
Okay.
You asked. Okay.
Sorry.
Why do I have?
5 is up here.
What's that?
This is the 865.
No, the 865 is on Ingram Hill,
Oh, okay.
and the 82 is at the Broome County Airport at the radar site.
Okay, so there's.
Okay, now to answer Alan's question, why did I do that? Okay, how many have gone up Route 81 and got to, Castle Creek exit, gone up over 2 Mile Hill, and tried to get back to Binghamton on the 865 repeater. It doesn't work very good, does it?
No.
No, because on Ingram Hill, the transmit antenna is on the south side of the tower. It's a triangular tower where that back leg is due south. So that means the flat side, the broad side of the tower is aiming due north. Okay, get your map out or your compass or your GPS or any of that and look. And Route 81 out of Binghamton goes directly north till it gets to well past Whitney Point and Marathon. Then it starts cutting eastward. Well, as soon as that starts cutting northeastward, then you're good. Then 865 comes back in. So you're traveling north. Whitney Point or from 2 Mile Hill on the Whitney Point side of 2 Mile Hill, up past the rest area north of Whitney Point, and then getting up toward Marathon, pretty much at least to the Whitney Point rest stop. You need to be on 82 because you can't hear 865. 82 is at the airport. I can be at the airport on the north end of the runway. And was it Swan or Swift Road? Anyway, it's on the north end of the runway. I can look and I can see the tower. It's at Peace Hill, which is south of Whitney Point. When you go up by the Buddhist temple and the whole works on the top of 2 Mile Hill, and you look on the left, you see a few towers on that west hill. That's Peace Hill Road. The county's got one of their new towers right up there. So I can see that tower from the airport. So it's line of sight. So why the two is 82 covers good up north of there. I've got some friends that live in downtown Sayre. One guy lives within eyesight of Robert Packer Hospital. He can't hear 865 good at his place because he's shielded by Sayre Hill, which is east of Sayre. But he can hear 82 fine because the signal where he's looking is he's following the corridor. And once again, you look at the map and the signal was following the Route 1786 corridor, and it's looking that way toward the airport rather than back here. But likewise, get down to Wilkes-Barre, before you get to the Wilkes-Barre Hamfest, or down where the Mohegan Sun casino is, I can drive on the road that parallels 81. I think it's 309 or 311. 315. Okay, that sounds right. And so anyway, it goes from up by Pittston or the exit. It goes from Scranton to Wilkes-Barre, but it parallels the west side of 81. I can be on that because that road is going like this. When I'm on the hills, I can, with my mobile and the RAV out there, talk back here to Binghamton on the 865 because that antenna is on the south side of the tower. So the people in Wilkes-Barre can hear us real good down there. But yet in Whitney Point, you can't hear us. That's the terrain. So that's why the two transmitters. Now, so okay, we answered that question. Now, why some of the receiver sites? Well, the same way, if you try around here, like with 7.3 or some of the other repeaters, they work in some places, other places they don't. Well, by this here, we've tried to put these to fill in the gaps. So like from here with a repeater on Ingram Hill, and Ed Rose has got it right from his house because he's in a little dip. He has trouble getting into the 7.3 repeater at night for the StarNet because even though he's on a hill, he's got a hill in between, and you can't see Ingram Hill from there. But here, when you guys leave tonight and you go and you look over and you see all those towers, you're looking right at Ingram Hill. It's line of sight from here. So anyway, what happens is when you're traveling the Route 26 corridor from, Chocolat, down by where the, Red Catholic Church is on the hill at, Chocolat, from there, clear on up to Vestal. You can, with this receiver right here, you can be in communication on the repeater. Try it with 7.3 and it don't work. Because the signal isn't getting up out of the valley. At the Redmond, what used to be the Redmonds Club, right down here at the corner of Powder House Road and 26, right across from a motorcycle shop. You can pull in that parking lot. And I kid you not, move the car a foot one way or the other, and one way you're into Ingram, move the other way, and you're into the receiver at the airport or what have you. It's that sensitive because I've run the test. And Bob can testify from Vestal Company 2, depending on where you are there, you may or may not get into this one at Copernic or not. Why? Because you can't see the doggone tower from station 2. Because where it is sitting back up here and this hill is sloping way off. Well, down here, there's Company 2. Tracy Creek Road, same way. So anyway, long story short, we try to put these receivers in spots so they hear. And fortunately, in most cases, they do. And so it's working out good. Now, so the last to finish up on this is the rest of it. And we got to imagine a few things. Okay. How does the signal get to the airport and how do we go through all the shenanigans that I've been telling you about? All right. At each site, we've got one of these remotes. So that's there. Okay. Now we come on down. There at the airport. I've got a tower there, 30-foot tower, and all it's got is antennas like this. Most of them are five element or so. Look at all different directions. I got some pictures on my cell phone I could show you, but and a few of you guys have seen it. And there's antennas, vertically polarized, pointing every which way. Well, those are pointing to where the receiver sites are. So one is off to the southwest. Well, that's here to Copernic. Another one's pointing over to Twist Run Road. Another one's looking east to Old State Road. There's another one that's looking more east. That's to pick up Navager, and that goes on. And then at the very top, there's a black one there, and that's aimed southwest. That's pointed right at Ingram Hill. So now what we do, so it comes in from one of the one or all of the remote receivers. And it comes into a magic box, which I don't have here. It's called a comparator or voter. So imagine a box here that's got feeding into that box 6 receivers like this. That all they are doing, each receiver is listening to the transmit output of each of these remotes. So this one's on one frequency with 1 PL tone. Another remote is transmitting another UHF frequency on a different PL tone. They're all coming back to separate receivers that are listening to those frequencies. So then coming out of that receiver, it goes into this box. It's a voter. It takes those 6 signals coming in and it looks at them and says, okay, I'm going to try and pick which one's the best one. In a real world, it picks the best one every time. If I spent thousands of dollars for that voter, it would do it. If I had a Motorola voter, it's seamless. When it votes, you don't even know what it's voting to because it's all a system, unified, all the same kind of receivers. Everything works together, but that's thousands and thousands of dollars, which hams don't have. So we got a more basic type of thing. Anyway, what this voter does is as soon as it sees a signal, it checks it for signal to noise. So it's doing it on all up to 7 channels. It's got the capability of 8 channels, but 1 channel on one card It's a 4-channel card. I can only use 3 for receiver because one is taking the output from the other card to feed into this, to connect them so I can get the multiple. So I can go up to 7 sites coming in. So that voter is looking at any signals that it hears coming in, and any of these UHF receivers, that's looking at them all and says, okay, I'm gonna pick one of you guys. And it does it. The only thing is that, okay, you got Copernic here listening, and you got, and this happens quite often, and you've got Twist Run Road. All right, and then you got like at Lanky BHD out there in Weltonville, or you may have some other people, and they're sitting midway between them. So both receivers are picking up the signal. Now, which one do I go for? Well, sometimes it's a roll of the dice. Now pick one or the other. The one fallacy of this system, the cheaper one, is it doesn't have what they call a vote lock. The ideal thing is it picks one receiver and says, okay, I'm staying with you till you go off the air. But this voter we got, they put some other features in it, so they took the vote lock out. So what happens now, you know how some people, and I'm noted for doing that, shiny objects or different things distract you? Well, that's just what happens with a repeater. It's sitting there, we're talking in the morning, and Copernic is the one that's hearing the best. So it's voted to that. All of a sudden, conditions change a little bit, and somebody's signal gets better. And as soon as another receiver carrier comes on to that voter, it sees another one coming into the pack. It says, hey, I got to go look and see if you're better than the other. You know, is the grass greener on the other side? Well, when that happens, it's a jump. So you will hear people lots of times in the morning be talking, and there'll be a skip in their voice. What's happening is that voter's turning around going to another channel.
Wasn't that advantageous if you're mobile?
Right, I was thinking.
It can be, yes. What it does is allow it to follow it more, but also it can allow it to hunt too. Instead of get on one receiver and stay there. No, this is jumping back and forth. So one, you can, with a vote lock, you can have it where it would lock onto one receiver and you go down into the hole and get noisy. Well, until it sees the loss of that signal coming in from that receiver, it's still going to stay locked right to it. Where with this one, as soon as it sees another signal come on, it's going to jump to it. So you get the dropout. But a good Motorola system, and they've got a real nice system, the way they do it. Of course, once again, they're using a constant signal coming in from their receivers, be it phone line or microwave. Hams, we cannot transmit a continuous carrier, but the Motorola with using microwave or a phone line, as their receivers are constantly talking back to the voter. And the voter is looking at that noise coming back on the phone line. The unsquelched audio, even though there's nothing coming in on the receiver, it's checking the quality of that phone line. And say the phone line noise is up. You know, you got some storms or the wind's blowing or something, and this particular phone line isn't good. The Motorola system will say, yeah, I'm not going to even bother looking at you. You're noisy. You're not going to be any good. Because in two-way radio, they want full clarity. Loud and clear, or it's now no good. None of this, hey, say it again, I'll try and pick you out of the noise. So, like that Motorola system, it's looking at that all the time, deciding before a signal ever comes on, which ones are available and which ones aren't. And then when the signal comes on, it says, okay, I'm looking at all you guys, I'm picking you, and that's it. And they stay with it, but they're also watching. So if something else comes better, it'll switch right over to there. But it's a sophisticated system. And the other thing it does is back at the voter, and this is where it makes it hard for hams to modify it, is it sees the when the carrier comes on, it's a loss of tone or something or other. It's got to see that for a fraction of a second before it starts voting. So it wants to be sure that I got a signal. It isn't just a blip in the phone line. So it's real sophisticated, but these things work, they work good, but it's bucks, big bucks, more than we can afford. But anyway, so much on that, off that track. But anyway, so we come in, we go through the voter, it picks the signal. Then what I do right now at the airport, because I got problems with a controller up there. And once again, I got the new controller, put it on, but it's an old programming type of system, and I'm not a computer guy. And so you computer guys could probably figure it out real easy, but I'm still trying to learn it. So I got to learn some of the programming plus set levels. So it's another one of these when I get around to it type thing. So in the meantime, I'm working with one port off the controller. So what I do is I come out of the voter and I've got a UHF transmitter there. That UHF transmitter is connected to that antenna on the tower aimed at Ingram. So when it comes up, it keys that transmitter, a UHF signal goes to Ingram, fires up to 865. Well, normally when the controller is working, it also keys up the 82 transmitter directly. But since I only got one port on that controller working, what I do is that UHF transmitter that's transmitted into Ingram, I've got one of these sitting right there with an antenna just about like that on it. And it's receiving that signal that's going to Ingram, that UHF signal. And guess what's on the bottom channel? The output, 146.82. So then the transmit antenna, that goes to the 4 stack dipoles that's up there. So so now what happens when talking about the delay, since this repeater has got a built-in delay into it for some reason or other, the 8.2 is always running behind the 8.65 a little bit, so you get an echo. And so that's it. One of these days it'll get corrected, but that's another one going on, because I've got you know, like I say, one more remote site, Avenger Hill, but I also got a site that is going to be another repeater. I'm already coordinated on a frequency and the whole works, 147.945 in, 147.345. And that's at Laurel Lake. Well, where's Laurel Lake? Well, you ever heard of Aquaga Lake, Scott's Aquaga Lake House? Well, there's a lake right near that called Laurel Lake. There's a tower there. It's a county tower. And same thing, 4 stack dipoles. One of these up there aimed toward the airport. So that will be a repeater on that frequency. And then on the repeater also, you can take one of these, because this is both the transmitter and receiver, go into here, and you got a link radio. It's either receiving back from the airport or it's transmitting to the airport. And there's your link. Or I can get even lazier and let it listen to the signal that's going to Ingram as a receive, then transmit on another frequency back to the airport, run it into that 7th port on the voter, and do it that way. So so in a nutshell, big nutshell, that's the whole thing. The downside of this is, I keep my fingers crossed and all that. Okay, 2 things. First of all, what happens if the power goes off? I got you covered. Each of these at the site, it's also got a power supply and a 12-volt sealed lead acid battery, size 24 battery. So that will keep these running for hours. And at those county sites, they got an emergency generator that within 30 seconds or so, the generator starts. But it's been times that the generator didn't start because of problems. These keep right on a run. At Ingram Hill and, or no, wait a minute. Back up. These are backed up with a UPS. One of those APC UPS, just like you get for your computer. Because since they're at sites that have got emergency power, basically, I want the power to stay on these till the generator starts. Well, why do I need to do that? That's extra work. Remember this thing is scanning? All right, well, one of the things that Motorola radios do is, if something goes wrong, they want to go back to channel 1. So everybody hears the main base station. So this goes back to channel 1. Well, so then you can get the case where, hey, works fine on 265, but I can't use the 8.2 side at all. Well, then Ford hops in his car, drives to the site, goes up there, we push the scan button and it starts. So by putting that UPS on it, just to keep this keeps on scanning until the generator starts. So the receiver never sees that there was a power failure. At the 8.2 transmitter and the 865, since those transmitters are transmitting like 50 watts at Ingram, a UPS won't hack it. So what I've got there is 12-volt sealed lead acid battery. And I've got, if you guys were listening today, we were talking about, I've got Samlex isolators. What it is, it's got 2 Schottky diodes in it. DC from the power supply through one side, DC from the battery through the other. They count up on the anodes of those diodes and go to the repeater or to the transmitter. And then what they do is they've got a resistor across that diode that's on the battery side. So they're putting a little trickle charge onto that battery all the time. So the battery is flowed right off the power supply. The only thing you have to do on your power supply is you have to raise your voltage from 13.8 up to about 15 to overcome the 6/10 to 7/10 voltage drop in the diode. And so that's the way I do it. And once again, with that 12-volt battery at the airport, we can go about 3 days on the 8.2 repeater before it goes down.
And you found out the hard one, didn't you?
What's that?
Didn't you find that out the hard
Oh,
one
yeah,
one time?
yeah, there was times last summer and it was doing weird stuff in the morning. And of course, everybody's telling me what it could be and what can't be. And I says, well, I won't know till I get up there. When I walk in and I look and the fans, they're going, they go, oh, I know right off the bat. Batteries are down. Put the voltmeter on, 8 volts. Well, no wonder. How many people got solid state stuff that runs at 8 volts instead of 12? Well, when you got the computer or the controller and the voter, that logic stuff, it may run 5 volts off its other supply, but it needs more than 5 volts coming into it to work. And 8 volts just doesn't cut it. So, but basically we can go about 3 days on a power failure at the airport and stay on. And likewise with the receivers, each of these receivers at the airport that's coming in on the links, they're backed up by another 12-volt battery and isolator on it. The 8.2 transmitter has got its own separate battery on it. And I believe the controller and voter is off its own battery also. So if one battery goes down, the whole shooting match doesn't go down. We still keep some of the stuff. Yes, Neil?
How much is the battery life affected if, like, there's a 3-day power outage, we're all gonna be talking to each other, find out something. I mean, how much does that degrade the battery life?
The more you talk, the worse it gets.
So, yeah, okay, is it linear, does it go all at once, or?
I don't really know. I don't really know because I haven't been there when the battery's gone down.
Right. Okay.
I've always been down there after the battery's dead.
Well, you said it's sealed lead acid, right? Those do tend to be linked.
Yeah. And so, okay, let's see if there's anything else. So, no, yes.
These 400, well, you said UHF, these UHF links, are they in the ham bands?
Yes, they
Oh,
are.
they are? Oh,
Yeah,
okay.
they're oddball frequencies.
What does that mean?
Well,
Basically,
they're,
spin the dial and
they're,
select-
they're non-standard repeater pairs or what have you.
Okay.
But they're all legal ham frequencies. See, what I did is I picked frequencies that are not on repeater frequencies because I don't want to take a chance that one of these remotes kicks up here and boom, the repeater down in Wilkes-Barre comes up alive. And so I pick oddball frequencies. Plus the other thing is that, and you can't necessarily believe what's written on these. The other thing is is I try to keep some of these frequencies quiet, so I don't have a bunch of people playing games with my HT. I'm going to go on the link frequency, and I've had some people do this. I had one guy at 3 o'clock in the morning, is Kerchunkin, and I figured out who it was. He's a member. He was playing some games, and because he thought he knew more about UHF than I did. And well, he was playing games at 3 o'clock in the morning, trying to do some of this stuff. Well, he was keying it up. I went out, and the other thing I've got at my house, I'm lucky, I'm high on a hill. I can hear the signals coming back from all these remotes. So and each has got a little different characteristic sound. So you listen to what's coming out of the repeater and what I'm hearing on that, and I can tell which receiver it's coming in from.
But aren't those highly directional?
Yeah.
I would think it would be real point to point, you wouldn't have.
Well, I'm 2 miles away from the airport.
Oh,
So one way or the other, the signals are kind of passing by my house.
oh, I see.
So it works. I've got some beams also that are aimed at some of these, but basically I can narrow it down to what receivers are keyed up, and I can also, by another oddball frequency, I can cut off those into that voter or what have you. I've also got a relay card in there running off another radio that I can open the COR line from these receivers so I can isolate them. So Ed's down at his place. He's playing games. He's messing around with his new bullfang that he won tonight. Or whoever won the bullfangs. He's on low power and he's playing games. Well, I look and I keep hearing this kerchunking and what have you. I listen. It's coming off the old State Road receiver. All right, it's somebody on the east side of Binghamton. Somebody within sight of Old State Road. It's not being heard good here at Copernic. I'm not hearing it good on Twist Run. I'm not hearing it off of Lyle. It's coming off down there. So then you listen and what have you. And lots of times I can pin it down. And sometimes with some of the radios, they got characteristic sounds. One of the common ones that people do, they get the new bullfang and they don't turn the Roger beep off of it. Well, beep boop, beep boop. Okay, who got a new radio? You listen for a few days. Yeah, I got a new radio. What'd you get? A bullfang? Yeah. Okay. No, know who that was. And I had one night, 3 o'clock in the morning, and in case you wonder, I sleep with the radio on. I got an HT. You know, it's like I'm
What do you want to know?
right. I got it. It weighs around the bed right next to my pillow.
Yeah.
And it's monitoring.
I
So
wake up at 3.
3 o'clock one morning, kerchunk, beep, kerchunk, beep, going on and on. That's enough of that. Get on the bed, go turn on the radio, get on with my regular lingo. Station playing games on the repeater. Would you please identify? Well, the fellow that he was brave enough, I got to give him credit. Hi, Ford, it's such and such. I didn't think I was bothering anybody. I was trying to get my radio going. Well, I'm still listening at 3 o'clock in the morning. You're still kerchunking without identifying. And don't do it anymore. And but I've had a few people that, well, I'll do it when Ford's asleep and he won't know it. Well, I got news for you. Because I also got another radio sitting there listening to paging frequencies, so I know when the fire departments get toned out. And when somebody comes to the alarm at Copernic to find out what's going on at 5 o'clock in the morning or whatever that was. Or no, that was around midnight, I think, if I remember right. But anyway, so that's it. Yes, Greg.
Who pays for the cavities and all this stuff?
Okay. Years back, the Susquehanna Valley Amateur Repeater Association was formed back in 72. At that time, Barra didn't want any part of repeaters. We are an HF club. We don't mess with repeaters. So some fellas, a lot of them were IBMers. They saw the need after the Agnes flood of trying to communicate on 6 meters in Elmira. It didn't work. They made out better talking on CBs than they did ham radios. So they came back and says, hey, we need one of those repeaters. And at that time, we had a place in town called VHF Engineering on 120 Water Street in Binghamton, across from that technology center. He was making repeaters. He says, I'll make a deal with you. You get serial number 1, first off the production line repeater. I get to play with that, make changes on that, and the whole works. So that is the prototype test repeater. But it's yours as long as I can mess with it. So that was, our first repeater was some kind of converted Motorola that I don't know what it was because I was just getting into it. But then the VHF engineering one came. And so we did that. Then after that, we put in a GE Master Pro, which was a solid state repeater with 2 type finals in it. And then later we moved up to the GE Master 2s like we got. The Repeater Association, we used to collect dues, $12 a year and what have you. Ed and Rick, some of the guys, Bernie, some of those remember it. Over the years, we got more and more of these repeaters that were privately owned that went on the air. And the owners says, I just put it on the air for the hams use. I don't want any money for it. Well, let's face it, hams are cheap. So now, do you want to pay me pay the club $12 a year for helping out the repeater, or would you rather freeload on some of the other repeaters? Well, that's what they did. They freeloaded on the other repeaters. So over the years, we went down and down. We've still got some money in a savings and checking account, because on some of these sites that I used to be at, I paid electric bill to help the people out. So I got a little bit there. That's the emergency fund. So if something goes bad. Some of this other stuff, years back, the county says, Ford, I got some extra money for ham use. What do you want? What could you use? Well, I could use 3 duplexers. Okay, we could get them on our account or what have you. So they bought me three Telewave 6 cavity duplexers. I says, okay, at Ingram, it was recommended to me that I put a ferrite isolator on, which is a device that RF coming down from other sources coming toward the repeater. You don't want it backing up into the repeater because it can cause all kinds of interference. So it's this thing, it's like an off-ramp, exit ramp, runaway truck ramp. So here's signals coming in from the sheriff's repeater or what have you. They're coming down. Well, instead of mixing in the repeater, this turns around and gets shunted off to a dummy load. This dummy load, that you see right here, that one says Telewave on it. TWL35, that's a 30-watt, a 35-watt dummy load. That goes into one of those ferrite isolators. And so that RF coming down gets shunted to that dummy load. So your RF from the repeater is going up the antenna. The 2-meter signal is coming down, same coax, but other signals coming down, they come down, we don't want you, over the dummy load you go. So I put that on at Ingram to just to be a good neighbor, so I didn't cause problems and they didn't cause problems to me. But Broome County's been nice that they helped out. They saw the need for some of this stuff of what we're doing, and they made it so we could be into this stuff. And okay, now question comes, what happens when Ford's not around? Well, there's a fella that's very good with a technical end. He taught me a lot of what I know. He knows basically how it's put together. He's worked on these radios, these types of radios, so he knows how it is. And I've also told Chuck Rogers at the county that when I can't take care of the system anymore, it's going over to the county. So it will be owned by the county. And if they want to keep it running, they can have the Motorola shop that's working on their new trunk system and the whole works. They can work on this. And some of this equipment that's going to be there is equipment that's coming out of service from the county. So it'll be genuine Motorola radios on a different frequency. So when I die, the repeater will live on. It may not be with the voter and all that stuff. It may be standalone repeaters, but it will live on because the rest of these repeaters, okay, the 7.3, That's privately owned, but well, one of these fellows that's my contact, he's also the one that would be kind of taking care of this technical stuff or the know-how on the repeaters that I've got. But the rest of the repeaters around here, most of them are all privately owned. The people that have them are getting old, just like I am, and the rest. Some of these repeaters will go dead. In Pennsylvania, they've added a lot of repeaters that the owners, private owners, have died. The repeaters have gone dead. The frequencies come up. Some of them that Jeff DePaulo down there and some of the others have grabbed onto those frequencies, put repeaters back on the air. They got some of them where they can link them together and some of that. So it lives on, but it's different people. But my hope is the one thing is that I've worked years, spent a lot of hours putting this system together, and hopefully it'll live on after I'm gone. So that's the thinking on it. But after I'm gone, it ain't gonna make any difference anyway. So you do what you want, you know. So okay, Josh, you got a question. You've had your hand up, I think. So I don't want to ignore you.
Well, actually, I've gone with 4, but the most recent one was why do you use lead acid instead of lithium for the backup batteries? You mentioned for the
okay, well, it's a real good reason. The batteries were free. There was a place, and I'm not going to say, but there was a place that these batteries were used on a UPS system. Well, you guys that know UPS systems, every few years you have to replace them, whether they're bad or not. Hey, Ford, I got a whole batch of batteries. You want them? Yes, I can get them in my car. I'll take them. Okay, here's the hand truck. Roll them out. So that's what I did. And years back, some of the other batteries I had are orange batteries. One of the fellows that is a member of BERA, he's in another area. He used to work for GE. At some time back in their early days, when they were starting to mess around with electric vehicles or something they were doing, they bought a bunch of lead acid batteries. And these are the ones that are about that long, about that wide, about that high. And they weigh that much too. You pick them up. That's not pulling your Group 24 battery or what have you, or your Toyota or what have you, and put it. These take some weight, or have got some weight to them. And they had a whole pallet of these. And this guy, they wondered what to do. Well, this fellow that's a ham, Tom Appleman is his name, AB2HS. He comes to the meeting sometime in the summer. He worked there. He saw these. He told the guy, he says, I know some guys that can use that. It could be used for amateur radio. Would that be all right? The guy says, sure. So he calls Brian and I up. Hey, Ford, if you want these, they're here. Come over. So, well, Brian had a pickup truck. Nice Dodge Ram pickup truck. We went, got all the batteries. Well, and these were brand new batteries. They were still in the boxes, still with the tape on them. And they'd been in storage for quite a while. Well, we used quite a few of them. Well, one by one, they're dying on me. And so I'm using some of these others that I've got. But I've also, in some of the cases, like at the Lyle remote, I need the battery for there, and that was back before I had these. I went and bought a tractor battery, just like I use in my tractor. You go to Tractor Supply or one of those, come back with one of those, put it on, because you know, that remote running, most of these transmitters here are probably running 10 watts, 5 or 10 watts. Because the other thing is, you see with those radios, the size of the heat sink. Well, something Motorola and some of these commercial guys do, they don't worry about heat. Because most people using two-way radios like Tops, Fetterman, and the whole works, they're not Ford. They don't talk till the timeout time goes. They're short transmissions. So all you gotta be able to do is sync these long enough. Some of these radios, okay, this bottom one, this Max Track, which is used as a receiver, they've got a timer in them that some use a temperature sensor, measuring the temperature of the heat sink, and then start backing the power down. The Max Tracks and their programming, it says, hey, if you've been on for so long, the heat sink is getting hot. So start backing it down. we had a max track at one of the sites, and it would start off good. And the longer we talked on it, the worse the signal got. Well, then we found out that, hey, that's backing the power down. So maybe we were starting at 10 watts, and by the time I got done talking, it was down to about 5 watts. And backing it down. So thou shalt not use max tracks for transmitters, receivers only. So then so what do? You put a fan on, just like I have here. Put the fan on, the fan runs all the time, run at 5 watts, it keeps them cool. The worst thing is with a lot of these mobile radios, using them for continuous duty, you don't have a big enough heat sink. And that includes the fancy radio you got at home, your mobile. Put that on 50 watts and start talking and see how hot that heat sink gets. And if you don't stop talking and let that heat sink cool down, well, pretty soon you'll find out how much it costs to replace the power amp module. Because they do go. And like it says, like with all my radios, you'll find they got one of these fans mounted on the back of them. Why? You guys know how much I talk. And I stress the radio, and the way I test these is key down at the power, and keep a watch on how hot it gets. When I can't keep my hand on that heat sink anymore, okay, you got 2 things: put a bigger fan on it, or drop the power, or do both. If you can't keep your hand on the heat sink, it's too doggone hot. And that's my sophisticated test for it. No special test instruments, my hand and common sense. So, okay, Josh, did I answer all your questions, or you got 100 more?
I mean, I can ask you like 3 or 4 more if you want.
Okay, go ahead, fire away.
So, is a cavity filter basically just a big capacitor?
No.
Because you mentioned about how it goes up and down. I know some
Right,
very
okay.
big capacitors.
Okay, yeah. It's like a capacitor, but no, it's a resonant cavity. And as far as the rest of it, I'll let you read up on that, because it gets pretty involved.
Is it like a waveguide or something?
Sort of like that, yeah. Yeah, it's a tuned section is what it is. It's like a tunable piece of transmission line or what have you. But I'm not the engineer, so I don't know all the what's of it. But it's you tune it to resonant, and it does magic things. So
Yeah. It works by magic.
right.
What's the power rating of the cavity filters? I think you told me before our repeaters are only pumping out like 60, 65 watts.
Most of these are rated, I think, for about 250 watts. There's some of these smaller ones. 50 watts max on this here. That's the one for the mobile duplexer, 50 watts. Because you do, since you're taking out frequencies, notching it, and some of that, you're producing some heat. Resistance, okay, you're trying to get through that narrow door. You're going to have to squeeze a little bit. Well, that's the same thing that happens with the signal. Well, when the signal gets squeezed, it turns it into heat. And so you have to keep these, keep them cool. So, okay, any more questions, Josh?
Last, somebody else have one?
Okay, well, your last question, then I'll get hers.
Okay. So, since the receivers are both, it's like the tide pair you have there, because it's listening on one frequency and sending out on another, and it's through 2 different antennas. That's why it doesn't need a cavity filter or a
right, and also it's on different frequencies.
Yeah. Different antennas and different frequencies.
Frequency separation and antenna separation. But the biggest thing there is the frequency separation. Okay.
Are they bigger than 250 watts? And like, what's the most that they ever build?
Okay. There are, okay, you're asking repeaters, are there repeaters higher wattage than 250 watts? Oh, okay, the cavities. Okay, basically, for two-way radio and what have you, the biggest base station or what have you is what they call a quarter kilowatt, 250 watts. Motorola, GE, or any of those, They had some in big cabinets and what have you, meters on the top, big tubes in them, 250 watts max is what they put out. Now you can, and say you're talking with broadcast TV or some of that, some of them are using filters that are a lot higher power. So they're bigger diameter. I've got some cavities at home. Some of these right here that are 2 meters that are that big around and they stand that high. But those things are good, I think, for 500 watts, 300 or 500 watts. And if you want something else, this right here, you ought to see a cavity for 6 meters. Or how about for a 10-meter repeater?
Ooh.
The doggone cavity is about this high. Because it's got to be a quarter of a wavelength or eighth of a wavelength at that frequency. Okay, quarter of a wavelength at 6 meters is around 8 feet. So that's a pretty good sized cavity, but lower in frequency, bigger it is. Bernie.
Okay, I'm trying to figure out this folder system in my mind, but all of these receivers have a transmitter and they're transmitting over to a folder, but they're transmitting on the same frequency, a UHF frequency. Right?
No, they're not on the same frequency, not the same UHF
Okay,
frequency. They're separate. Yep. Each
one
of
is
these
different.
each of these 6 receivers at the airport
that's
is
what
on a different
so-
UHF frequency and a different PL tone.
And they're non-stable.
Oh, okay, the PL tone has it. Okay,
Right.
I was wondering how they were keeping from clashing with
Yep,
each other.
yep. And some of it too, if you look the way I've got the antennas, the very top antenna is the transmit to Ingram. The rest of the antennas are all below it. Why? Because I want to keep as much of that transmit signal going to Ingram off of coming in on the receivers.
Good.
And I have a good one, and I haven't cleared it up yet. And thanks to this guy, I found it. At his house, where he lives over here, he's lots of times, especially when the storms, he's using one of his Hongqing or what have you, Chinese radios on free power. And he's talking, giving us weather reports and what have you. Well, most of the time he's got a good signal. Well, sometimes he's terrible. Well, what's going on? Well, I check and he is, I listen to those links coming in. He's good because he can see the tower here from his house. So, okay, he should be coming into this Copernic receiver with no problem at all. Well, why is he noisy? I listen to my house, to the Copernic signal. Nothing wrong with that. I hear that good. Why is he noisy? Coming out of that voter. And what is it? Oh, Ed, you must have something wrong at your house. No, I don't, Ford.
I can hear it with one, if you hear me on 865, I'm on 1 watt with an HT. I
So-
can see the antenna.
So anyway, what it boiled down to is at my house, everything is fine. Well, no, if the problem is at the receiver site or at the airport, you got to go to the airport and check it out. So, and one day Ed was home from work or something. Or maybe I went up on a weekend. I says, Ed, I need your help. I says, okay. And on the voter, I can flip off the other receivers. And I could take the receiver, so the one coming from Copernic, I just turn the volume up on it. Speaker right there, I can hear what's coming in. I have Ed talk. He's noisy. He's terrible. So he's talking. Well, then pretty soon he comes back again. He starts talking, he's fine. All of a sudden, he goes down. What is going on? Well, we got the power supply up there. It's what they call frill resonant power supply, but basically what it does is it hums all the time. It's supposed to. Well, I'm listening, and as soon as that power supply gets the load on it, that's when the 8.2 transmitter comes on. It makes a different hum. That's when he goes out. Reach over. Okay, I'd keep talking. Put the power supply off for the 8.2 transmitter. He's fine. Aha. what was happening is the signal going to Ingram. Here's the one antenna. Down here's the other antenna, looking at here. It looks like it's enough distance, but evidently it isn't. There's enough of that signal that's going to Ingram that's coupling into this other antenna. It's doing what they call descents. The easiest way I can say descents is you and I are talking back and forth, and you guys start talking. Pretty soon you got a voice like mine, and you're louder than what I am, and can't hear it. Right. Because of all this other noise around. Well, that's descent. It descents other non-desired signals can drop the sensitivity of the receiver down. So it's not hearing as good. Well, that's what was happening. Well, why was it doing it just on Ed? Because Ed, with his free power rig, he was only capturing one receiver, the Copernican receiver. West Run Road wasn't hearing him. Old State Road wasn't hearing him. So when he was on that free power HT, he was only voted to one site, this Copernic one. And the signal, when it got to the airport, was getting desensed by the signal going to Ingram. So so I know what it is now. What's the fix for it? Part of it is I changed the power level on the signal going to Ingram. But probably the next thing is when I get up there is I may lower that antenna down the tower a little bit. Try and get a little more separation. I also tried, I've got a UHF cavity that's smaller that I'm using as a notch cavity. And what I'm trying to do is notch out that link signal that's going to Ingram. Because what I've done is my receivers are all on the links coming in there. They're down in the lower end of 2 meters, like the input to the repeaters. And my link out is like with the output of the other. So I'm receiving low, transmitting high. So I'm trying to get the 5 megahertz separation between what's coming in on these receivers and what's going out on the link to Ingram to try and isolate it. But for the rest, it never shows up because they're into more than one receiver. So when this one gets desensed, Twist Run picks it up and everything's fine. But he's the only one that the problem. But I had to go to the site and really dig around to find the problem. So that's what it was. So the problem isn't solved. I know how to work around it. So
you've got receiving antennas on UHF and a transmitter on UHF. So this is desensing.
Yeah. I try to keep a 5 megahertz separation, but it's still, and the thing is, these radios are mobiles. Okay, they're fairly selective, but they're not designed for noisy environments. They're designed to put in a mobile and what have you. So they don't have the good selectivity in the whole works that you would have on base station. The other thing is, with repeaters, one of the last thing I'll say about with repeaters, most repeaters do not have preamps in them. We all want preamps. Oh, you got to be able to hear more. Let's get more amplification there. Well, if you want problems, put a high gain amplifier on a repeater, take it up to Ingram Hill, and then tell me about all the problems you're having. Because the preamp hears everything. Noise, other signals you don't want, all kinds of stuff. And so most of the repeaters and what have you do not have a preamp in them. It's an optional equipment to put the preamp in them. Because for Motorola and then GE and what have you, you put the preamp in, you're asking for more problems. Because the rest of the taxi cabs and all that are at a site. Now their signals are coming in and your customer is hollering because every time their unit is trying to, the sheriff's unit is trying to call back, he's getting clobbered because of the taxi cab guys talking or something like that. So keeping the preamp out, you got less problems.
You want a preamp at the antenna, actually.
Well, but that can still give you the problems. And just like you guys on HF, there's times when using the preamp is good. But then there's other times when the signals are strong enough, all the preamp is doing is bringing up more noise. And, but also there's some people, you know, well, on 40 meters, you don't use the preamp. Well, sometimes if the signal is real weak, turn the preamp on, you might be able to hear the guy that you can't hear with the preamp off, but you may bring the noise level up also. But, so anyway, that's the, that's the basic of it stretched out. So, now you're all smart, so you ought to know what's going on. Okay.
A little bit of housekeeping and we're wrapping up. If we could take a second, grab a chair and throw it on the side, because Drew's got something going on tomorrow. The planetarium is gonna be in here. So he threw the chairs up for our meeting, but, they need it open for tomorrow. And, all right, we'll see you guys next month. And don't forget, there'll be another radio,